Hello everyone, and welcome to part 2 of the review video for my open mock paper. The questions in this second section have quite specific tricks. By specific tricks, I mean that if you have not seen the ideas before, it is going to be pretty difficult to figure out. And so hopefully these are very useful. But if you have seen the idea before, you may feel that this is not that hard. Now let's start with question 8. It is an equation which if you were given a less than b less than c, or rather if you weren't given, you would just say that a, b, c are probably the same. And funnily enough, if you did not read a less than b less than c and you just thought that a, b, c are all equal, you will get the correct answer, which is 90. Sometimes, by the way, this is if you're desperate, just whatever they tell you, just ignore the condition if you can get an answer and just hope that that condition was redundant. But there is actually some logic to this. The logic to this is that do they need to be the same? No. But if two of them are the same, then it would work. Right? Clearly, if A and B were the same, then these would be the same, these would be the same, these would be the same. That is not useless information, because that means that if I were to shift this to the other side, by the factor theorem, which also applies to multiple variables, a minus b is also going to be a factor, and so is b minus c and c minus a by symmetry. And now that you see this, it is going to be that, oh, I'm just left with degree 1, this is degree 4, and this is already degree 3. So there's just one more factor left. And it is not too difficult to just compare the coefficient of any particular thing, let's say a cubed b, and see that it has to be that I've already got a squared b, or rather negative a squared b, it's just negative a plus b plus c. Right? So this is going to be necessary for it to work, and you can check it if you want. Or you can just know that if it's symmetric, a cubed b has the correct coefficient, means so will b cubed c and c cubed a, right? Because it's not symmetric, it's technically cyclic. The implication, therefore, is that a plus b plus c equals to 0. And if a plus b plus c equals to 0, we can use our other identity, which is that a cubed plus b cubed plus c cubed minus 3abc is a plus b plus c times a squared b squared c squared minus ab, ac, and bc, which is 0 since this is 0. Before we move on, I would just say that you could actually have potentially guessed values that work. In retrospect, right, a plus b plus c equals to 0, and you've got 30. So how did I know that ABC exists? I chose 30 for the reason, right? A equals to, let's say, minus 5, b equals to 2, c equals to 3 would have worked. And 2 times 3 times 5 is a relatively guessable combination. So, well, you can kind of see what is going on. Sorry, no, yeah. I wrote the wrong one, right? It's not minus 5, 2, and 3. It is minus 2, minus 3, and 5. Yeah, otherwise that multiplies to negative 30. Okay, so that's why I was looking at it and I said, that seems wrong. Yeah, minus 3, minus 2, and 5 were the one that I thought of, not minus 5, 2, and 3. Okay. Next up, question 9. We have a diagram, and we have got a parallelogram, a circle, and basically nothing else. Now the lengths that I've got are 20, 2, and 3. I can use this hourglass pattern, as I call it, to get some ratios. Because of the similar triangles, 5 to 20 means I can call this x and 4x, and then y and 4y. It's a parallelogram, so this is y, this is 3y. The good thing about this is that I can now just use power of a point on the two things that are not on the circle, which are c and m. So when you're trying to use power of a point, look for things that are not on the circle. I mean, obviously, if there are lots of things not on a circle, then you look for those things that are not on a circle and have lines going through them and hit the circle at 2 points or a tangent line. If you just have a point that is floating in the middle of nowhere, then don't use that. Okay, so for m, x times 4x equals to 2 times 20, which would give you x equals to root 10. For c, you get y times 4y equals to 3 times 25, which gives you y equals to 5 over 2 root 3. Incidentally, this is more or less enough in terms of like we have got so many lengths that you're not surprised we can now get the area. It is up to us how we want to find the area. We can just, for example, use a sine or cosine rule. Just because of the fact that we are in a circle, however, there is the fact that this is a cyclic trapezium, and a cyclic trapezium is always isosceles, right? Because this angle is equal to this by parallel, but equal to this by cyclic. And so that means that, in fact, this 5x also comes here and here. And so you have all the dimensions of the parallelogram. Okay. One way that we can do it is that we can use the small triangle CEM. And just use the cosine rule. Okay, and then after that, use that to get sine theta. Okay, that simplifies to root 157 over 20. Okay, and then from that theta, I can just use my usual half AB sine C formula. So half times 4y times 25 times sine theta, which is this, times 2, because it's the whole parallelogram. Okay, and so your answer, m plus n plus q, is 498. This is just the manual trigo portion of it, right? So the power of a point, once you have those, and then you just grab one more length here, then we are ready to just use the cosine rule. In fact, based on what I wrote down there, we don't even need actually to label this 5x down here, right? But I just wanted to point out that you have an isosceles trapezium and isosceles triangles here as well. Don't separate trigo and geometry questions, especially for the SMO Open. A lot of times you will do a question mostly with trigo and a bit of geometry, or mostly with geometry and a bit of trigo. So that is something that we want to allow ourselves to do. Question 10, simple trick, but if you have not seen the idea before, you should know. Right? So it's that if n is congruent to 1, 5, 9, 13, 17, mod 11, 13, 15, 17, 19, I effectively want to make these match with these. The common difference here is 4, the common difference here is 2. So how do I do that? It makes sense that if this is common difference 4 and that difference 2, I can sort of multiply these by 2 as my target, and now just say that, oh, the difference is 21. So n plus 21 would be 22 mod 11, which is 0, 26 mod 13, which is 0, and so on. So it's just 0 mod 11, 13, 15, 17, and 19. All of these are co-prime, so it just means that n is 11 times 13 times 15 times 17 times 19 minus 21. And I just asked you mod 1000, so as you're multiplying, you just keep the last 3 digits so that it is not so ugly. When you see that it is like this, don't combine them 2 at a time necessarily. That may take quite a while. You instead just suspect that there is some nice way that you can merge them all at one go into congruent to 0 mod something. Okay, so I'll just give the numerical value, which is 814 mod 1000. So specific trick, right? If you have got things in a chain like this, try to adjust one of them to look like the other one, and this is how it works for this particular problem. Another specific trick, question 11. Specific trick, it has a logical motivation, but it is still a specific trick, which is that I want to make it telescope and all cancel out. I know that all of these have a difference of 18 degrees, and therefore I should try to write basically almost a product to sum for tangent. How will I have this? Well, I could actually get it from my tangent sum or difference formula, and since the differences are fixed, I'm going to use the tangent difference formula. Alright, so this implies that for all of these, if I make this the subject, sorry, one extra bracket, this is equal to 1 over tangent 18 times the difference minus 1. Basically, there is also a product to sum-ish thing for tangent. Which allows me to now just apply to all of this, and I know that it will telescope. you have tangent of the bigger one minus tangent of the smaller one all the way. So I can just fast forward it all the way to this. Except that I need to check how many terms there are. Right? So the number of terms is 110, meaning that there are 110 of these minus ones. This is 0 because 1980 degrees is a multiple of the period, which is 180 degrees. So it disappears. So it's a very specific trick. The product to some idea on tangents, and it works because they have a common difference. What to say about these sorts of standard tricks is that we want to understand them before the SMO, but during the SMO itself, there will still be one or two at least that we've not seen before. So if something looks too weird and you can't figure it out, just skip it first, because maybe it's a very specific thing that is hard to think of if one has not encountered it before. Question 12. We call a number evenly increasing if it has an even number of digits and they are consecutive digits arranged in ascending order. Given that there are exactly 5 prime evenly increasing numbers, what are the last 3 digits of the sum of these 5 numbers? Okay. 5, I have no opinion on whether this is a lot. So if I want to start, let's start with 2 digit because I think those will be the easiest to check. So 2 digit, I only care about odd. So 23 is 1. 34, no. 45, no. 56, no. 67, yes. 78, no. And 89. Oh, that's already 3 of them. Now, 4 digit is the next one to check. Again, it has to end on an odd digit. So 2, 3, 1, 2, 3, 4, no. 2, 3, 4, 5, no. 3, 4, 5, 6, no. 4, 5, 6, 7, I'll check it later. 5, 6, 7, 8, no. 6, 7, 8, 9 would be divisible by 3. So no, so this is the only possible one. Now I'm starting to get a bit annoyed by this because I'm thinking, how am I supposed to actually go and check the 6 digit and the 8 digit ones, right? But hang on a second. If it's 6 digit, the digit sum is going to be a multiple of 3, right? Because there will be 3 pairs. So that definitely doesn't work. So those are all out. And for 8 digit, there's only 2. 1, 2, 3, 4, 5, 6, 7, 8 definitely doesn't work. So 2, 3, 4, 5, 6, 7, 8, 9 is the only candidate. And there's no easy way to check it. But then there are exactly 5 prime is told to you. So which means that it must be this 5. So the trick is the exactly 5 is not just to kind of like confuse you or to just like, be a description in the question. I need to tell you that because there's no way to check 2, 3, 4, 5, 6, 7, 8, 9 is prime easily. Okay, so last 3 digits, you just add this up. And numerical answer is 535. Someone's going to ask me, so how did I actually check that 2, 3, 4, 5, 6, 7, 8, 9 is prime? I use Wolfram Alpha. The thing is that as a question setter, right, I'm allowed to use these tools as long as I make sure that you don't need to use those tools. If ChatGPT worked, I also would use ChatGPT to go and set the questions. However, it does not set Olympiad questions very well. So the questions are from me. But the calculations, I will use technology. The SMO also will use technology, but they will make sure that if the only way is using computations, then they will give you the information that makes that not necessary. Okay, so remember that the question setters are not insane. They have not forgotten that factorizing 8-digit numbers by hand is not very likely to happen. Finally, question 13. How many Well, how far do you need to go for n such that this is true? And if you're confused, you realize that, oh, okay, so there are n layers here and n minus 1, 2025. So there's one more layer on the left, right? Otherwise, if let's say that there were the same number of layers, and it's going to be really big, and I have no idea how I'm going to calculate that. But for this one, it's not surprising that one more layer is going to be quite valuable after a while. Okay, so let's just look. Right? If n equals to 2, obviously, no. If n equals to 3, still much smaller because this is just 81, right? 2 to the 81 is a lot less. N equals to 4. Now, this is not that clear instantaneously, but if you were to just calculate 4 to the 5, that's still 1024, right? So 2 to the 3 to the 1024 is still obviously smaller than this because each layer is less. That brings us to one where the same argument does not work anymore because 5 to the power of 6 is pretty big. It's 15625. And the question is, how do these two things compare? Here's how they compare. Basically, the idea is that if you have got something on top that is so big, it is worth a lot more. Why? Because if let's say it's 4 to the power of 15625, I can just sort of like donate some stuff below, right? And here's what I mean by donate. I can just give, like, let's say 4 squared to here, and then this 4 squared goes into the 3, and now this layer is very big. And likewise, if let's say that I wanted to make this bigger, I can just take out, let's say, okay, 4 to the 5 is smaller, so I can take out something like 6, and just estimate, right, 2600, where this is also going to be more than 2025. And this humongous thing down here is so much bigger than this that, I mean, I can just afford to give a little bit down to the 2 as well. I'm not going to write this, but it is quite understandable, right? That I can just give a factor of, let's say, 3 to the 16 down to here, and I will still literally have almost as much as I started with. Maybe I'll just write it. It looks funny, but you just understand why these are actually very far apart. Right? I just borrowed 3 to the 16, and what do I have left? I have still got 4 to the 6 to the power of 2600 minus 1. That's all I have. This is still so much bigger than that. And so I can safely say that the answer is n equals to 5. Of course, why do you do these specific things? It doesn't need to be so specific. You do these things because of the specific knowledge that in general, having a big power at the end of a giant chain has more value than having a big power below. And that's the reason why I have the motivation to just bring some of it down and still leave so much stuff left over at the top. Okay, so and then this brings us to the end of our second section. If you have any alternative methods, feel free to share as usual, and we will continue on with the next two parts in the next couple of days. Okay, so bye bye for now, and see you very soon.